And with this, we will now move on to our last session for the day, a panel discussion that is going to focus on analyzing and optimizing digital advancement and technical opportunities for reducing heat rate. A detailed panel discussion on how, through aggregated data, digital surveillance and monitoring, advanced analytics, AI, and machine learning, power operators can not only monitor heat rate variances, but also track changes and compare real-time data to identify scope of improvement for improving heat rate. I would now like to invite our session moderator, Mr. Kaushal Vaishnav, who has multifaceted experience in the energy sector across business development, project management, and regulatory. He is currently working across the energy and infrastructure segments. He has been involved in EPC as well, consulting projects of national and international repute, working largely across state and central government entities. He has also worked with Fortune 500 companies on multiple projects based in Asia, Africa, and the Middle East. Thank you for joining us. I would also, ladies and gentlemen, like to now introduce our speakers. Due to some unavoidable circumstances, Mr. Boban Anto, Director, Exactspace, who was to be joining us today, will not be able to join us for this session, but he has been kind enough to share his detailed presentation with us for all of you. This presentation is going to be available on the Council of Enviro Excellence, that is the CEE event website, post the conference, along with our other speaker presentations. Introducing the other speakers joining us today, please welcome Mr. Sandeep Chittora, Technical Director, Industry X.0 KPMG. Mr. Chittora has 17 years of experience in developing client-centric solutions. He has developed digital twin of steam power plants and led programs for improving energy efficiency of thermal power plants through modernization, flexibilization, and digitization. He has also spearheaded transformation programs through flexibilization of thermal power plants. He is currently working as a technical director at KPMG, and in his current role, he leads Industry 4.0 transformation programs for varied industries. His presentation today will focus on how AI machine learning can help in reduction of heat rate, how to go about digital transformation, IT/OT integration. Various use cases of technology such as digital twin, drones, predictive analytics, pattern recognition, etc. will be focused upon. Also, our next speaker for today, please welcome Mr. Subhramanyam E Edamana, Digital Anchor Plant Engineering and Design Cluster, Power, Steel, Chemical, Metals and Mining, Tata Consulting Engineers. Mr. Subhramanyam is working with Tata Consulting Engineers, Bengaluru. He is presently anchoring digital operations in power, chemical, steel, metals, and the mining business units. He has more than 15 years of global experience in the field of power, water, and digital. He has presented and published many international conference journal papers through his tenure in the industry. He is a member of the Indian Desalination Association and Institution of Engineers, and he is a subject matter in coal, gas, cogeneration, renewable power plants, T&D, advanced digital technologies, digitization of plants, environmental regulations, emission control systems, waste heat recovery, zero liquid discharge, desalination, water treatment, as well as sustainable water management. We will have Mr. Sandeep Chittora make his presentation first, followed by Mr. Subhramanyam. The panel members will have about 25 to 30 minutes for their presentation, and the moderator would have 10 minutes for a discussion post the presentation. Requesting our moderator, Mr. Vaishnav, to give your opening remarks and take the session forward. Over to you for an informative session.
Great. Thank you so much, Riyal, for the kind invitation, and I'm glad to host this session today, and glad to see our industry experts joining here today. And I'm really expecting to have a good and knowledgeable session today with our key panelists here. So without taking much time, because I think definitely we are running a little short on the time as per the timeline, so I will pass it over to Mr. Sandeep. So Mr. Sandeep, over to you, and looking forward to have a nice session with you. Thank you.
Thank you, Vaishnav, and thank you, CE team, to provide us this opportunity. Today, I think we are in the world of transformation, and I am going to talk about how these transformations are happening in the thermal power plants. So I'll just share my screen. Let me know once it is visible. Can you see my screen?
Yes, we can. You would just need to go to the slideshow mode.
Sure.
Yes.
Yeah. So I'm going to talk about Industry X.0 for power plants, and why we call Industry X.0, because the transformation that is happening currently is at a very, very rapid pace. Today we are talking about Industry 4.0, and in soon, I would say in very near time, we are going to talk about Industry 5.0, and I think there is already talk happening on Industry 5.0. So that's why we say this transformation is going to happen continuously, and power plants are requiring to adapt it. Uh, Initially, I'll focus on the pillars of the Industry 4.0, what constitutes Industry 4.0 in thermal power plant. Then I'll speak about Industry X.0 transformation, why it is happening, what are the levers that is helping it, how the benefits are getting achieved, and then talking about delivery across the value chain, digital twins, UAVs in power plants, maintenance management, and then summarizing the use cases that we have. I was expecting Mr. Boban Anto also in the call, and I was actually anticipating that he's going to talk about more on the performance side, and that's where I tweak my slides on to the maintenance management. However, I'll try to add in my capacity whatever best I can on the performance aspects as well. So if we see the pillars of Industry 4.0 on the thermal power plant, what we see is the emergence of autonomous robots. And here, once we talk about autonomous robots, these are like handling material. These are going inside the machines, inspecting them, giving the real-time information and so on. So that is all is happening as in supported technology, which is emerging and helping the thermal power plant. Then there is also an element of system integration. And once we say system integration, it means that various components now starts talking to each other, exchanging the data from one system to another system. We know that in power plant, there are many PLCs, many SCADA and DCSs are operating in parallel, wherein the information from one system to another system becomes a challenge. But now, because of the Industry 4.0, this is happening, and this is something what can also get implemented in every thermal power plant to have one common truth of the information. Once we start talking about the system integration, we also need to be cognizant of the cyber security, because our power plants are the assets of the country, and we need to make sure that these power plants remain secure. They operate, and there shall not be any sort of a intrusion from outside, which can hamper the operation of these power plant. And for that matter, for every asset, it is going to be a challenging task to ensure that the all entire power plant's component remains secure. In terms of technology, we also see 3D printing getting emerged, wherein like parts which are of the nature which is available but like not required and just kept in the stores for a very, very long time. Power plants are now adopting the thoughts that why not having a 3D printer and then produce those parts as and when these are required, instead of keeping their inventory. We have an element of simulation and digital twin, wherein we can actually simulate all the assets, all the processes of the thermal power plant in terms of digital twin. That can help us in making our decisions more stronger, more data driven, and then we are more confident in taking any step. And nowadays, if we see, our thermal power plants are being asked to flex a lot. They are required to go down deeper into the minimum technical minimum load, and even lower than that what their original capacities are, and then ramp very fast. So in these scenarios, digital twins are going to be very much required to understand how the power plant will behave in those situations, because now the assets are older as well, and they are not as in new state wherein all the information and all the I would say all the processes were very smooth. Most of the control logics are not operating currently. Most of the control loops are not tuned properly. So all those situations can start emerging as soon as we see through the lenses of digital twins. Now coming to Internet of Things, as I said, machine-to-machine translation of the data is going to happen. They are going to talk to each other in order to provide that, okay, now this particular machine is going to stall or going to halt for a time, and then certain other pump or heater has to take the load. Then coming to augmented reality is going to help in order to train the plants in order to facilitate remote monitoring, in order to facilitate remote experts coming in and then seeing the outages through their eyes and then guiding the team at the site itself, because it is not possible to bring all the expert at the same time on the into the plant and then get the best of their knowledge. But this is now being made possible by implementing augmented realities. Big data, because we see all thermal power plants generate humongous amount of data. They are like, I would say, data generating machines nowadays. And most of the time, power plants also don't know that what to do with that data, because that is always it should be treated as a gold mine sitting within the power plant, how the power plant has operated in past and what can be leveraged in order to make it future ready. And that's where we see an emergence of cloud computing. Most of the information is going to cloud and then coming back in order to drive the decisions. So how our conventional industry or how our conventional power plants have been looked. We used to have sensors like pressure, temperature, DP for the flow measurements. Then we used to have PLCs, SCADA, maybe also the ERP, wherein like we used to maintain how the coal is coming and how the spare parts is being managed, which is utilized being by our operation, maintenance, and governance teams. There was also an element of strategy, transformation office, and change management always, which used to give the asset efficiency, stockyard operation, help them to ash handling, reducing the minimum downtime, used to help in FMEAs, and then also for compliance related topics like SOX and NOx. What is now happening is we see a lot of other type of sensors are coming in. We see AR, VR getting emerged. We see wearables are happening and IoT sensors are coming in. RFID tags are coming in. We are seeing emergence of video and image analytics also coming in. And once these sensors are there, applied into the power plant, what we see various technologies that can get implemented. For example, you see drones are coming in. Digital twins can be made. Blockchain is also happening, like wherein like you know that okay, the one information is always truth in all the other systems, all the enterprise related systems. We see AGVs are being used in the thermal power plant. Artificial and machine learning is being utilized extensively. And once we implement these digital technologies, what we see is boiler tube leakages can get detected. Once they get detected, even after their detection, how we can reduce the downtime of that particular plant is wherein we see the emergence of UAVs coming in. Blade failures can get detected. Generator, rotor, and stator fault can get detected. And all these are helping us in predictive analytics. So that is where we see that all this happening together is nothing but an industry X.0 transformation journey. And in this journey, all these technologies has to grow together, has to work hand in hand. And what our thought is that all the systems are now going to talk to each other. This is something what was not possible, that what the original systems were not able to talk to other system, is being made possible through the industry X.0. And what we visualize is that once this all integration happens, for example, like ERP system talking to the DCS system, similarly CRM system, like how my demand is going to happen tomorrow, what kind of patterns I could see, what will be the weather things that is going to happen, which can drive my control people to make their decision that how they are going to control the plant tomorrow, and what is they are required to generate at what type of a coal that they have got. All this getting together as in threaded thing, and we call it as a digital thread once the all integration of all systems happens. With this integration of all the systems that is there in the power plant, what we see is huge benefit coming to the plant by utilizing the single source of truth, because now they know that this is the right information and basis that they need to take the decision. And typical benefits that we see is heat rate improvement in the order of 2 to 3%, reduction in the forced outages up to 15 to 20%, reduction of the capex that is required for maintenance is 10 to 15%, increase in plant profitability by 5 to 10%, and O&M expenses are going to get reduced by 10 to 15%. So this is where the technology is actually helping these thermal power plant in order to be more agile, more profitable in the future. So this is an example wherein we see that if the systems gets integrated, how the value can get accrued. So a lot of things is being talked about in coal handling, coal, and then coming like taking the coal from coal mine and generating the power. The entire value chain has to be understood well in order to know that how the GCE values has got changed over the period of time, right from taking it from the mine and then transporting, storing it in the coal yard, and then finally burning it in the boiler and then generating power. So if we collate all this information in a real-time manner, in also in a holistic manner for a wherein like every system is able to talk to each other, we see the value getting emerged. What we can have in that case is like we can even reduce the ship transit losses. So if sort of any transportation losses that is happening can be and then if they are getting stored, so portyard losses as well as the transit losses in the rake can also be detected. Even yard losses, which is like for the storage, that can get detected. So this is where like these are able to deduce that where the losses are happening and where we need to attack the problem exactly in order to get the maximum benefit of this data transformation that is happening. What we see is that we will be having the master data getting stored in the plant. There will be many dashboards coming in, giving the information in real time, what is happening, what kind of coal has come, how to get it utilized in order, what kind of power it will be able to produce. Then there will be also an emergence of NLP, which is like a natural language programming, wherein like people in different languages will be able to talk to these devices and then get their work done. RP is like all sort of automation, which will be through robotic process automation. So all RPS will be getting implemented, and then there will be an emergence of mobile apps, wherein a worker will go to a particular asset, take an image, and then get the information like what is the DCS parameter on this particular assets are and how he has to react onto the particular asset that he's seeing currently in the plant. That is where we see that a lot of across the entire value chain, as soon as the reconciliation happens for the data, then the value emerges and we are able to pinpoint where the losses are happening and where we need to take the action. Now, once we are able to have a data layer enabled, so at let's say basis things are available now in the power plant, what we can do over it. The next thing that we see as in power plant getting embraced or getting embraced in the power plant are digital twins. And what essentially are digital twins is they are basically the replica of the assets and they are basically replica of the process. And I'll talk about like what is the asset twin and the process twin in a very short time. But they're basically a replica of the asset and the process that is there in the power plant. Now, how to actually go about digital twin? There could be various ways in order to go. You can either go for a complete digital twin of the entire power plant and then start making more and more or add more and more features into it. For example, you can have performance analytics as in one layer or one particular feature. You can also have predictive analytics. You can have automated report. You can have anomaly detection coming out of these twins. So what we see is that as in twin is, it will be having a real-time process data, which will be in the form of pressure, temperature, power, gas composition, and all sort of data that is getting generated. It will also be having itself the design data which has been provided by the manufacturers. So it will be having a characteristic curves, their design limits, and sort of a failure that has happened in the past. So failure data as well as the root cause analysis that has been done. So this is all the information that is contained in these twins, which will helping us in order to provide the real-time analytics. Like what is the expected performance of that particular asset? For example, if I'm talking about a simple pump which is operating in the power plant, if I have a certain amount of a flow or a pressure rise across that pump, what is the expected power that it will consume? And then we can compare that expected power to the actual power it is consuming in order to know if there is any sort of a performance degradation that has happened. These twins are going to send or throw away many sort of alerts, which is like out of design operation, because we have already embedded the design limits into this. So if any operation that is happening out of design, it will give us those alerts. Any sort of anomaly, which is like unexpected operation or unexpected deviation, which is not being seen by human eyes or not being seen by, as in like even high or low alerts, those kind of alerts will also be possible as an anomaly detection. And then it will throw away the performance advisory. For example, like what you need to operate or how you need to operate, what you will be able to do as in what if analysis. And what if analysis is going to be the a key feature of every digital twin. If you want to operate a particular pump in 50% load or a 40% load, what you expect out of that pump, how much flow it can handle, how much pressure rise it will give, that is something is possible through what if analysis. If you want to do a tube cleaning in the condenser, you simply run a what if analysis that, okay, I'll do a tube cleaning, what kind of vacuum I will be able to generate and how it is going to help me in order to improve the heat rate. So those kind of performance advisory is possible through the digital twin. Predictive analysis in sort of, if you have any sort of a potential failure that is going to happen, it will give you those alerts upfront so that you prepare your team, you prepare your plant operation and maintenance accordingly to tackle that situation. You become more resilient in terms of operation of that power plant. And then, of course, automatic reports, which is like a democratization of the data. These reports will be available to everyone. Everyone will see the same information, and there will not be any sort of a discrepancy in the information that, okay, this is talking something and I am talking something. And then we start debating that your data is right or my data is right. In this kind of an twin, we will be having a one source of a truth wherein everyone will start working towards improving that. And our view is like you can actually monitor or you can create twins of boiler, turbine, generator, condenser, pumps, feed water, heaters, that's pumps, fans, and air preheater, or any equipment that is there in the power plant, maybe any electrical equipment or anything, conveyors, for example. And all these can be converted into twins. What we see is the conversion of a twin will happen from or should happen in like one asset at a time or like one particular process at a time. And that is something you see, you take one equipment, you start creating a twin, and then as soon as you grow, you have more and more twins coming in, and then you start integrating the entire twin to get the entire power plant picture. So probably you can start with, for example, like one ID fan twin, and in one ID fan twin, what you will be having is like a performance analytics coming in, giving you insight about how the expected power should be in various operating conditions, what is the actual power that is being consumed, and then it will give you the gaps where it is going to give you insights about like how should you really operate and which areas you are operating better, where you are not operating correctly, where you need some sort of an advice from the experts of ID fan and so on. Similarly, on the predictive maintenance, it will give you insights about whether the vibration pattern that is being seen by the control engineers or like the control instruments, whether that data is accurate or not, whether the data information that you are finding is going to give you any sort of an alarm for a potential failure that is going to happen, and then you prepare yourself for that particular failure and accordingly address that. So this is one example of, I would say, asset twin. So wherein like you are having an asset and created a replica of that so that you can do all sort of analytics across this. Similar sort of a value chain will be, or a twin will be a process twin. For example, a steam or water flow or feed water flow is happening across pipe, and any sort of a gas is also flowing across the pipe, and there are number of bands, number of turns and then joints into this, various gases getting mixed. And now once you do a process twin, you can find out like because of the pressure draw or because of the bends that are there and because of the mixing that is happening, what will be the right composition at the end, what shall be the pressure drop in that particular aspects. And if you are able to calculate it, and if you are able to simulate all those things, you are able to know that now there are leakages happening or something is missing here, and then you start taking the corrective action. That's the power of digital twins that is going to get delivered to the power plant, wherein the operation and maintenance engineers are going to make use of it a lot. And what we see is that maintenance engineer will not be remaining as a maintenance engineer. They will become predictive maintenance engineer, because they will be much more making use of all these such tools. Similar are very, I would say, exciting example is a intelligent UAV use, and wherein like what we see is a typical drone which is being customized, made for power plant operation, is now getting utilized in the power plant. As soon as any sort of a boiler tube leakage happens, this drone goes inside the boiler, and it detects or it finds out where the leakages has happened, how big the leakages is, and accordingly they plan the scaffolding that is required to be uh, created inside the boiler to address that particular leakage. Now you don't have to make the entire scaffolding. You don't have to plan for the entire scaffolding, because now you know the information that where the leakages happened, and before actually you go for the entire cooling down period and then make the scaffolding for 2 to 3 days, you avoid these 2 to 3 days. And similarly, you can also give this data, visual data, to experts sitting remotely, that this is what the situation currently inside the boiler, what they suggest, what kind of corrective action they should do. And I have a very illustrative example for a 660 megawatt unit. And now, if we are able to save 2 to 3 days of outage by utilizing such asset or such sort of technology, what we see is 30 million units of generation will be additional if you are able to do 2-3 days advancement, which is nothing but 10 CR as in revenue. And I'll just share like this kind of a how this is making sense. So currently you see this UAV getting inserted from the bottom of the boiler. It goes across the water wall, going up in the water wall, and then actually detecting where the leakages are, additionally capturing all the information. So now you see that it is going up to the water wall. So it's basically controlled by an operator, who is standing below, and they're also watching on their tablet the information inside the boiler, and accordingly guiding it like where to travel and how to travel. So it's not like you have a complete plan already made and you start searching for that. That is also a possibility, but currently what has been done on this particular exercise was there is a person who is guiding it to go inside and then capturing the image. So you go further, and then you see some sort of like, I would say, small scales that is there. These are the bends wherein like those gets inspected whether they are in right shape or not. Here you detect that there is some sort of a failure, which is then you will start capturing more information around it. Because if there is a one failure, like you also need to see where is like in the vicinity if there are some other areas which is required to be attended, because you don't want that one repair happens and then again in very near time or very soon time you will have another failure coming in. So that is something like you would like to see. Once it gets detected, you also see other surfaces. For example, like here you have certain sort of a, I would say, soot or getting deposits which is there. Once it captures all the information, again the operator who is standing below just calls it back and then get this information collectively. And basis this, you are able to save the entire planning of the scaffolding where it's required to be done or not. Another, I would say, additional program that every power plant can now follow is an RCM, which is reliability-centered maintenance plan, and in which what you do is basically you find out that various system mapping, which is at an equipment level, and those critical equipments are mapped into the system. Then their reliability is assessed based on what is the current maintenance practices. FMEAs are done, all sort of root cause analysis has been done on that. And then you do a PF analysis, which is an impact analysis, that in case if this fail, what kind of impact could happen. If those fails, then whether you have a spares available for that, or whether the spares are long lead or short duration item. How much will be the life cycle costing if those kind of components fail, like whether any sort of a better technology should be used for those equipment or not. This creates your entire maintenance strategy, and then you see an optimization. If some parts are required to or failing continuously, you probably go for a design change, or maybe a maintenance plan according to that, and then you implement that technology. So or implement that entire RCM plan. What we see is RCM plan. This transformation can drive up to 10 to 20% of the cost saving, and this results in the improvement of the availability. So what we see is typical unplanned breakdown reduction happens in the range of 15 to 20%. Planned downtime reduction happens in 10 to 15%. Shutdown overruns, which is like 3 to 5%, which I'm going to talk about, like how to tackle that as well in the subsequent slide. Repair and maintenance cost gets reduced by 10 to 20%. You have consumable consumption reduction 2 to 4%. Mean time between failure of the bottleneck machine is around 20 to 30%. MTTR reduction happening 30 to 40%. Inventory cost getting reduced by 5 to 10%. And shift from basically a reactive cycle or reactive maintenance plan to a proactive maintenance plan. This is basically possible now because you have more information, you have all the collected data for all the assets. That's where, and all the root cause analysis being done holistically, so that you have that information and basis that you can drive those decisions. Now, a very important, or I would say, the plan that happens around the shutdown or turnaround management. So if your assets are not working, you are not making money, and that's where I think the pressure comes in on every power plant to bring it very quickly onto the grid. So the expert industry experts usually see that even if they have a shutdown plan, usually the shutdown time gets increased by 10 to 15% of it. So if they plan for 30 days, it can go up to 32 to 33 days and so on. Basis the data that is now available and every shutdown or every outage that they have handled, now there could be a possibility of doing workflow automation. So most of the workflow that has been generated in the past can get generated automatically now, utilizing this data, which enhances the worker safety, and then can be used as an additive manufacturing thought or toolkit, that which parts I have used mostly, whether I can manufacture them as in 3D printer or not. Then we can also think about the confined spaces where if it is there in the plant or in the plan of wherein it becomes a critical activity, then we need to get it removed, because if you are having a critical activity as in to be done in the confined space, then you are bound to lose the time there. Some or other thing will happen, so we need to remove it from the critical path, and then you have some additional time available to work on the confined space. So on to workflow automation, what you will be able to get is you have enhanced traceability of the work that is being done. You know how much time the work has been repeated, reworked, and hence you improve the quality of the work. In worker safety, ensuring safety and do it right first time and all the time. Right parts at the right time. Once you have the 3D printers available, you are having an option nowadays to have a substitution available. Then you can plan that whether you need to do it now in terms of like in that particular outage, or should you plan it for the later. On confined space, as I said, that it should not come into the critical part. This is how you should plan your outages. You can have a digital view of the entire shutdown planning. You have a complete visibility, traceability to enhance safety, and this enhances the culture that is there in the organization that this can be done. So, in the sense, there is a theme which says that okay, now in past it has been done in 33 days. I'll target for the 33 days in outage. But But if the management sets the direction that the outage should be done in 30 days and utilizing these digital technologies, it is possible, then there is a cultural shift that is happening in the organization that says that yes, it can be done, it is achievable. And that is something like we, as in we come in and we say that, okay, this is a shift that we can make. Coming to very specific, or I would say use cases around the industry expert or transformation, which can be in the area of performance enhancement, predictive analytics, or in maintenance safety. What we see is, as you have any sort of a digital twin or data being continuously monitored, you have a possibility of early detection of any large performance deviation that is going to emerge. So if these degradation gets addressed early, if these scaling or if these falling gets detected early, you are going to get your plant operated most of the time at a highest efficiency. So what we say is efficiency highest possible every time and of everything. And then you always be focused on the controllable losses. Whatever losses that is happening there, how do you control them? That improves your revenue and the profitability of the plant. This reduces your losses and also the less cost to the repair, because earlier you repair of all sort of a smaller scales or smaller degradation that has happened, the cost will be less. Then you have possibility on the predictive analytics, which is like if the component has got failed, then of course the repair cost or the replacement cost is going to be huge. But if you also invest lot of data or lot of sensors, then also the cost is going to be higher. So that's where like the concept of predictive analytics comes in. Now you don't do it as a time based, not overdo or not underdo as well, and you do actually the maintenance as in like what is optimal. And this decision comes as in data-based, data-driven decision. You can have a possibility of spare part planning. You can also have a possibility of like having the critical spares always available, and then eventually reducing the inventory levels. On maintenance aspects, that the maintenance plan will be much more agile, as I talked about. You have more possibility of doing the opportunistic maintenance nowadays. And why I say opportunistic maintenance, if you run your power plant in part load or in load which is not the full load, I would say there are possibilities in area, for example, like pump or fan can get repaired once you are running at, let's say, 70% or 60% of the load. You can actually isolate one of the equipment, do the maintenance, and then again run at full load. If you have such opportunities available, you can actually do opportunistic maintenance, reduce your maintenance costs, and of course avoid safety hazards. With that, I say thank you for providing me this time. These are my ideas, and I am available for any sort of a question or discussion around it. Thank you.
Yeah, great, Mr. Sandeep, for the detailed discussion and your presentation. It is indeed very insightful. And before I put up my questions, I would like to ask our esteemed panelists or the attendees if they have any specific question to Mr. Sandeep, we can get that addressed. So it is open to you.
Sandeep, what is the cost of loading all these to a 210 megawatt power plant?
Prabhat, I would say like we haven't done as in like the complete transformation of one particular power plant, all things coming in together. This becomes, I would say, more of ROI sort of a decision. But before that, what I would say is the more need is towards the cultural transformation to really lead this, that yes, these helps, and then start working on the ROI side. So to be honest with you, I haven't like actually calculated how much it is going to cost for a 210 megawatt, but of course it can be worked out.
Cultural transformation today is all digitally controlled.
Yes.
You see our all Ola and Uber drivers. Whatever mentality they have, but they are controlled by the company. They cannot deviate from the route. They cannot take a different direction. They cannot stop for a long time. For everything, there is a check. So cultural transformation, this is India, right? India, we have been running these power plants in a totally manual way. Most of the manual interventions are there. And whatever automation was there, it has been always bypassed because that is our culture. So cultural transformation will only happen by the KPIs,
Yes, so Prabhat, very true. Like as I spoke on the shutdown management slide, that you have now possibility of rewarding as well as punishing. So what you choose is also your thought. Like once we said that Ola, Uber, we know that okay, whether they are derouting or not, it can get traced. Similarly, if they are able to give the better to customer services, then also they should be rewarded. So it should happen on both sides.
You talked about predictive analysis. We have been talking about it for almost 10 years. Now we
Yeah.
are only, right, from our earlier DCS businesses. Now only the name changes. Now you talked about predictive analysis. Now, most of the power plants are prone to tube failures. Major breakdown happens due to the tube failure, right? Now, I'm not very sure whether the system what you are referring to, like when you say twin, it is nothing but simulators. The way we used to use operator training simulator to simulate the conditions and see the performance, right? It is quite similar to that.
High fidelity simulators. You can,
Yeah, it is a self-learning kind of arrangement, which records all the kind of abnormalities and signal. Trips and alarms and everything. Now, my question is, even if you are able to predict that there is a hot spot getting developed on one water wall, we are not going to stop the power plant, to do that, until unless it fails because of two reasons. Your regulatory does not allow to do that, and the kind of regime we are in this country. So what is the benefit of this predictive, like turbine blade? If turbine blade is going to break, I'm not very sure whether you can really predict that IP turbine blade stage number 3, blade to 24 is going to be failed until unless you have a very, very high level of IIoT built in and all, which is not there as on today. So what is this in reality?
So yeah, so Prabhat, here I would say boiler tube leakage, I would say, is slightly complex compared to turbine blade failure. Nowadays, there are mechanisms in order to get the blade failure information based on the vibration patterns that it has. And that gets detected very accurately. But then, of course, it requires additional sensors to be installed, which is
You're
like a
talking about probably gas turbine. You're talking
gas
about
turbines as well as steam turbine last stage blades, like the LP turbine last stage blades. There is possibility. Only thing is, it is required to be, I would say, understand by, first of all, by the plant, and secondly, also being provided by the OEM, which is like knowing that how they have designed their blade and where those are, which areas they are prone to have failures.
Can it be embedded in old turbines?
It can be done in all turbines as well. Yes, it can be done on all turbines as well.
Has it been done anywhere in the world?
I mean, like, of course, like now, as soon as like the system matures, there is a element of new installation or new type of sensors gets installed in order to get those information. So, but then if the degradation or in sort of any sort of a cracks or any failure which has already happened, if it will not come as in part of a guarantee of that, but it starts giving you information which is of importance in nature, because if the last stage blade fails and if that is not available in your inventory, you are bound to have a very, very long time shutdown.
So
which is like
my last question, what KPMG does in all this? KPMG is not a system integrator. What are you trying to sell?
So here, Prabhat, or my thoughts that I had shared here is not to any sort of a system integrator role or something. What we say is that we take this journey with our clients in order to mature them, understand them, to make their visibility, that which kind of system and tools are required to get the full benefit of these technologies.
So the software and hardware is not recommended by KPMG.
Software and hardware recommendations, of course, are there with us, but then we are not the software and hardware producers. But then we know that which particular software and hardware is going to get implemented in order to get the full benefit of it.
All right. Thank you, Sandeep. Mr. Vaishnav, my questions are over.
Yeah, thank you. Thank you so much, Mr. Prabhat, for the detailed technical questions. So now I think I will take a little more leap on the commercial side of it, because I think more of the technical questions has been asked by Mr. Prabhat. So Sandeep, very basic questions. Definitely for every business or any solution to make its place in market, there are certain factors which we have to look at. So the very first factor is the implementation cost, definitely with Mr. Prabhat has asked. So if any utility or operator tries to implement the solution, what is the overall implementation cost compared to vis-a-vis comparison with its benefits achieved, like ROI or some other factors, which generally we do take into consideration before we implement any such solution. Also, the second part of the question is, what is the available skill set? Is it only specific to the management consulting companies like KPMG or the other big fours, or is it something you are going to support the utility to get that skill set to their operators? And third one is, what are the key examples of such implementation in India or abroad?
Sure.
So hope you can throw some light on that.
Sure, of course, Kaushal. First of all, the ROI or the investment that you see is depending on the case-to-case specific. If you are saying that we need to have a digital twin, and if you want to have a digital twin of one particular asset, maybe ID fan or a pump, it will be a very small investment and the ROI will be very quick, but it will not be high. But as soon as you start maturing it towards the entire plant, like you have boiler twin, you have air preheater twin, you have turbine twin, of course the investment goes higher, but then you also have the more information, and now you actually start clubbing all the power plant operation data into that twin and then churning that data in order to get more and more precise decisions. For example, it can give you an insight that you don't have to maintain or do a maintenance right now. You can probably do it 1 month later without having any sort of a huge failure coming in, and then you need to have a forced outages or something like this. So that is something you can get out of these twin in terms of predictive analytics on performance as well as on their failures. And that's where the ROI starts coming in. But our always advice is that start small and then scale fast. So you see that you start with very, very small units so that you have the entire organization learning about it, of how these operate. They understand what kind of data integration are required to be in place. And then you start scaling it to the larger components, and then have a full blown, like for entire power plant and entire value chain as well.
Okay. And then skill sets and
so yeah, in terms of skill set, we have set of experts from the sector who then handhold the entire power plant operation, guide them towards the entire journey for this transformation, right from the conceptualizing of like what needs to be done, right from the business case of each and every aspect that is required to be addressed. So for example, like a particular plant can see huge losses happening towards the shutdown management only. So therein we will be having a program running through them to have a shutdown management in order to reduce their shutdown periods, in order to reduce their inventory costs. So that is something like we handhold our client for the entire journey. That's typically.
Is it something you do till the time you are engaged, or is it something which needs a continuous engagement by the utility to have you as a team with them, or is it something you can knowledge transfer to their team also to operate or work on this?
Sure, perfect. So here the approach that we have is I do, we do, and you do. So it is like initially once the program management is being done, it is being done by experts who have I would say significant insights about it. They do it by themselves. Then it is being done together with the plant, wherein like we start imparting that knowledge to the plant. And then you do is wherein like we simply come out of the plant very remotely, handling them through calls or through communication only. and then the power plant itself is doing. So that's how the transformation happens. I do, we do, you
But
do.
still, the reliability still remains with you itself, right? Like your company, because even after they're operating, they have to rely upon you in
No, I
terms of
mean,
the
no, no,
calls.
no. I would say no, no. Once the transformation exercise has happened, they have learned the art of it. So it's not that we
Okay.
will be continuously remaining there or so. It's like transforming them itself. Once, that's why I said, like, in future, what we see is it will not be maintenance engineer. It will be predictive maintenance engineer, because they know that this is how it is to be done, and then they will take their decisions.
And when you are saying that this is the some percentage of the O&M cost reduction or the heat rate reduction,
Yes.
so when you have those data available with you, what is the benefit in terms of overall cost implementation of this program or the project? Because
So
when you are
correctly.
providing a solution and you are claiming certain results, what is the cost of implementation compared to the savings or the results we are getting after the investment? So
So
what
here
is
it
that
is. It has
ratio?
to be. Yeah,
Then
it has to be specific to the what we can say is like typical payback will be in the year in the range of, some solutions can have 6 months payback or even 4 5 months payback, and some might have even larger, which is like very small, but then those are like larger transformation. It should happen in 2 years, 3 years time. So that is like typical payback periods that we see is varying from 6 months to 3 years.
okay. And what are the examples where you have implemented the solutions? And many of our people are asking this question in the chat box. So that is very common, which people are really willing to know about it.
So here I would say specific use cases has been done in various industries or various power plants. Not the full transformation. We have not seen any full transformation happening in our country or as well as in the abroad, that the entire power plants got transformed. It's a journey wherein like they invest and then they get benefited, and wherein like the payback periods, as I've already mentioned, get accrued.
So what are those key solutions, if you would like to name them, or
So for example,
which has
like
been implemented in
yeah.
the India
So,
particularly?
yeah, so for example, like implementation of digital twins, you can also have a coal logistics program wherein like we do the entire value chain analysis, and across that, like how the CV losses are happening and so on. So that is something also being done. Shutdown management is also a program that is being done. These are key specific areas which is like driving the results into the plants.
But it has been done with the PSUs or the larger national utilities, or
Uh,
with the private players?
No, mostly private players. It has not been done like as in like PSUs or so.
Okay, so the adaptability from the PSU, the government side, is still yet to be
Yes, it
known.
is. Yes, yes. To be honest with you, yes, it is still to be explored. It is still to be worked out. Uh, that is right.
Okay, great. Thank you so much, Sandeep. These are, I
Thank you.
think, very basic questions from my side, including the questions we received from the chat box. Any other questions from other members? We are okay. We can take one question, or else we can move to the next session with Mr. Edamana. So I think hope that is okay, considering the timelines we have with us.
Yes, I would suggest we move on to the next presentation.
Great. Great. So now, thank you, Sandeep, for the nice discussion and the session. Now I will move on to Mr. Subramanian.
Thank
So welcome, Mr. Subramanian, for this nice session, and glad to have you here. So without taking much time, I would offer this screen to you and completely yours. So please take it up, and we are looking forward to have a nice interaction with you. Thank you.
Thank you, Kaushal. So you have given the sharing of
Yes, yes, I've already
screen.
given you the rights.
Okay, once again. Share screen. Okay.
Click on the share screen option at the bottom of your screen
Yeah,
and select your file. So you'll
sure.
have to open your file first.
Sure. Yeah, my screen is visible to all of you.
It's, I think, just I am not able to see a presentation, but
Yeah, it is just saying that it has started sharing the screen, but it is not yet visible.
you will have to open your presentation, and when you do just share screen, click on your presentation and share.
Yeah, actually what happens is there was some issue with the Zoom. Is it visible now?
Yes, it is. You could
Yes,
just go
yes,
to the
now it is.
slideshow mode.
Yeah.
Yes.
Thank you so much for the invitation and the opportunity to present at this esteemed forum. So thank you, C, for this opportunity. And thank you for the enlightening presentation, Sandeep. It was a great session covering almost all the aspects of digitalization for power plants. So, in fact, I have not covered those aspects luckily. Okay, so I'm focusing on more on the performance part. Okay, so at least the duplication is avoided. So today, what we are, covering in this session is the trends, the key trends in the thermal power sector. Okay, and some of the technological issues that we are seeing at the power plant, especially with respect to the performance. And what are the technological options that we can look at to overcome many of the performance issues and to optimize those the performance of the plant? And some of the solutions and what is TC's approach in this area? And what are the different technological solutions that are available from us? So this is the brief in terms of the session coverage. So I think the about TC, I think in the morning session, my colleagues might have already covered. So I'm not getting into the details of the overall solution, the offering coverage of TC. So we are one of the largest consulting firm in power, and we are also offering services across chemical, metals, mining, and digital. So digital being a horizontal BU supporting all the other domain services. We provide the top-up solutions in every domain that we operate with digital content. Okay, so because we have seen the technology is moving very fast, and there is opportunity to optimize the planned operation, construction, maintenance. Okay, so everything with the intervention of digital enablement. So the digital technology BU looks into the advanced technologies, including say 3D printing, productization, the computational fluid dynamics, finite element analysis. Okay, so all those additional advanced technology services will be provided from the digital BU, apart from the asset performance management, reliability centric maintenance, and so on. Whatever we are seeing on the digital space. So in power, we cover almost every aspect of the power generation, including thermal, nuclear, hydro, solar, wind. Okay, so within solar, we have ground mounted, rooftop wind. We have the on ground onshore or offshore wind. And also we are into the T&D side. So we cover the entire spectrum of power, and we are there in this industry with so many firsts being engineered for the country in India. So the first 800 megawatt Mundra was engineered by us. The first 500 megawatt at Trombay was engineered by us. So going along, so we have an obligation to support the entire digital journey of power plants, because we have seen there are a lot of changes which are happening in this industry, right? So let us look into what are the key trends that we are seeing in the power plant, especially in the power domain. So we have seen the whole changes that we have seen currently is a result of the climate change and energy transition paradigms. So energy transition is so fast. Okay, it is impacting everyone's life. Okay, and there is no isolation for power sector. Okay, and in fact, the power sector and the energy sector is the first one getting impacted by the transition. So a lot of renewable energy is coming onto the grid. So it is making a lot of variability in the grid. So we need to have solutions for, say, stabilizing the grid. And in terms of policy making, so we are also seeing, say, a lot of RE plus thermal bundling options are coming across globe, not only in India. And as a result of the renewable energy addition to the grid, so many of the thermal plants which are already designed for base load has to be in, say, a flexibilize the mode. So we have also seen, see, in 2015, the environmental regulations have come up, which calls for, say, FGD, SCR, all those things in power plants. So recently we have also seen, say, biomass firing policies have come out, and around 32 or 33 gigawatt of power is already experimenting with the biomass firing. So we have also seen people are experimenting with, say, ammonia as a co-firing agent. On digitalization, see, advanced process controls for the heat rate optimization, digital point solution. Basically, it's a microservices which is looking into the focused system or equipment and try to optimize the performance of that system or equipment with a lot of analytics and monitoring on that equipment. So asset performance management. So this is also like at equipment level, system level, okay, or at a global level, we can implement. So we will get into the details of that in subsequent slides. So global scenario of energy transition. So it's very clear 83% of the system capacity addition at globally from 2010 to 20 is renewable. And that scales to approximately, say, 256 gigawatt is added in, say, 2020. So Indian scenario is also not so different. So we have added around 37 plus gigawatt, say, from 2015 to 20. And we have also seen that there is a huge decline in the solar tariff, right? And which is actually causing the lot of financial pressure on the thermal plants, which are already having PPAs, which is higher than the tariffs from the renewable or from the solar plants. So from a timeline perspective, so it is very clear that the climate change and energy transition are driving the changes in our sector. Okay, so 2015. So when the Prime Minister has gone for the Paris Summit, the first regulations have come up on the environmental policies, environmental retrofits. So which basically look into the SOx, NOx, water, and yeah, all the emission related aspects from the plant. It also calls for the reduction of specific water consumption for the power plants. So 2019 CE has published for the overall roadmap for the flexibilization for thermal plants, because in 2015 we have set a target of 175 gigawatt of RE installed capacity by 2022. So we are very sure that the capacity addition from RE will be so huge, and it is going to have a lot of variability, which is going to infuse a lot of variability in the grid. So we need to have the for the grid stability measures, the countermeasures like, say, flexibilization of say thermal plants or installation of pumped storage plants or the batteries. So these are all which will be the aftermath of the renewable energy addition into the grid. So 2021, the revised policies have come up for the biomass co-firing with, say, 10% of minimum biomass firing, which is happening in the plant. I mean, which is mandated for the plants. And say, if the type of mill is not supporting, okay, we can also limit at 5% level. But these are all which is happening. And 2022, we have seen the RE plus thermal bundling policy, revised policies have come up. And 2022, after the, say, Glasgow COP26 summit, our target is for 2020 is 450 gigawatt of RE. So this journey is going to continue, and we will have more and more changes to the thermal plants. So that is the lesson we have seen from the type of events that we have seen in the last 5 to 6 years. So it is going to have a lot of fundamental issues in terms of ROI for this, especially for thermal plants. So about 43% decline in annual revenue potential for per gigawatt of installed capacity. That's what BCG estimated. So, and for the coal plants, due to the flexibilization, you will have a lot of additional cost in terms of maintenance, because these plants are actually based, I mean, it's all built for base load operation, meant for base load operation. So now we will be going to cycle the operation for these plants. So maybe on a day-to-day basis, we will ramp up, ramp down, or we will say we will have a scenario of start stops. Also, we will have part load operation for a longer period, okay, which will also have issues of efficiency drop for the power plants. So globally, we have seen these are the issues that are driving the changes in the plant. So how it is reflected in locally, okay, locally for a plant. So what are the changes we are seeing? Say part load operation for a longer time, which will have heavy impact on the heat rate and the efficiencies. So we have seen plant owners are experimenting with multiple type of coal, imported coal from say Australia, Russia, South Africa, and Indonesia, and so on. So which all has say different quality of coal involved. And we also started say blending in many of the plants for last couple of years. So our boilers are not actually designed for such kind of blending, or maybe the kind of experimentation on coal quality. So certainly you will have issues in the boiler tube leakages and performance of your plant. And due to the flexible operation, so you will end up in cycling the plant. So it also will have impact on your life, because every thermal or the metallic component is designed for a certain amount of thermal cycling. So, and its design life is predicted based on that. So when we are having say more number of thermal say cycling changes, so it reduces the life of your the component or equipment. So we are experimenting with a different type of combustion, and also we will have to lower the minimum thermal loads, okay, as a part of the flexibility. So I mean, as we all know, so flexibility has 3 different components. Okay, one is a minimum thermal load. So we also need to have say higher ramp rates, ramp downs, and we also try to minimize the startup time and shutdown time. So when we are lowering the minimum load compared to the technical minimums for which the plant is designed, so we will end up in seeing a lot of changes related to the combustion, especially if you do not have say so much of VMs in the coal. So you will have a lot of issues with the combustion stability. So the coal property and the load at which you are trying to operate as a base minimum will be a part of this flexibilization exercise, and it will have issues of stability in combustion. Auxiliary power reduction is one of the prime requirement of all the efficiency improvement exercises. And as a part of the flexibilization exercise, you will also see a lot of fluctuation in the water chemistry. So normally it is a very ignored area, especially for Indian plants, even though globally we see a lot of research and improvements in water chemistry. But in many of the plants what we have visited, it's not so advanced approach towards the water chemistry optimization. And for these localized impact, okay, so what are the different technologies that we can look at in order to improve the situation? Say part load operation and efficiency reduction, okay, so we can certainly look at some closed loop optimized solution which can optimize the part load efficiencies. Okay, so that is one of the say prime technology intervention that we can look at in the plants. So variation in quality and blending and combustion stability. Okay, so these are the two things which should be attended through some physics-based model clubbed with the data. And in order to have more predictability, you can also have the computational fluid dynamics models, okay, for improving the combustion of the boilers. So cycling and related life impact. Okay, so this is an area which many of the plant owners are actually concerned now, because the base load plants, when it goes for cycling, many of the critical parts may undergo stresses, thermal stresses, even though we have, say, thermal temperature sensors placed on many of the critical component. So the life of the components are going to reduce. Okay, so how to predict and how to take countermeasures for such kind of life impact for the critical equipments. So the technologies of help is, say, thermal stress analysis for the pressure parts, okay, and for the major OEM related supplied equipments. So, but for OEM supplied equipments, okay, so normally it is expected that they will be doing this exercise for the flexibility also. But apart from the main the OEMs, okay, so you will also have the pressure parts which are in terms of the critical piping and other pressure parts. So for which you will have to conduct a thermal stress analysis and qualify for the life reductions. So finite element analysis and thermal stress analysis are the key technologies that will be powering the countermeasures in this area. So auxiliary power reduction, basically, until and unless you monitor a equipment, you may not be able to improve its performance. Okay, that is the fundamental understanding for most of our plant operators and as well as the practitioners. So it is important to understand, important to monitor and on a continuous basis. And for all the critical equipments, specifically the HT connected high tension motors. So we should have a watch on all those HT motors and have proper analytics related to the deviation in aux power. So if the auxiliary power consumption is deviating beyond a certain limit, so we need to have certain analytics, say, built around the deviations in order to give the operator very quick understanding of what is happening for the equipment, for him to take a countermeasure very quickly. So digital tools will definitely help in this area. For water chemistry, this is an area where you may not see a quick improvement in terms of any action that you are performing on to improve the water chemistry. But you can see some changes with respect to, say, reduction in blowdown if you're improving the water chemistry. So maybe reduction in the startup times, and so that, because of the improvement in the water chemistry faster. And if you really maintain the water chemistry well, okay, it is like the blood of your power plant. So if you really maintain the water chemistry very well through proper monitoring and timely action, you will have very good return in terms of the reduction in the boiler tubes and the power cycle components. So you will also maybe see reduced, say, blade failures, okay, due to, say, depositions and all. So it is important to understand the water chemistry very well, okay, and use the best know-how available to optimize the water chemistry, because our water chemistry is going to see a transformed regime when the power cycle is undergoing a flexible operation, because it's no more a base load operation. So your power cycle chemistry also will vary. So it is important to monitor that also continuously and take action, so that we will avoid further deterioration of the power cycle related components of the failure. So what are the changes that we have seen? What are the variation of heat rate we have seen in plants? So this is actually I taken from a CEA report. So we have seen the heat rates are varying approximately, say, 24%, say 13% to 24% variation, okay, which is really costing a lot for the operators. So similarly for boiler efficiency variation, okay, so this also we have seen a change of around, say, 7% of variation. So these are all costing the operator a lot, and many of the say digital solutions that we can look at can actually improve the situation to a great extent. So I'm just seeing from a practitioner's perspective, okay, so how do we really approach the kind of how do we counter the trends in the thermal power plant sector, and how we can really improve by applying certain digital tools. So for the heat rate and boiler efficiency optimization, so we would look at a real-time closed loop solution based on advanced process control. Okay, so why we recommend these? The normal analytics or the predictions. Okay, so that is always good, but ultimately when my plant is going for a say a lower than the technical minimum thing, and when I'm increasing the whole range of my operation, the normal the PID controllers, okay, which are the final element which controls your entire process. These are all not tuned for the kind of operational changes that we are seeing for the flexible operation. And also when you are increasing the load range, when you're firing a different type of coal, so these PID controllers will behave totally different or totally unoptimized for the kind of operation that we are looking at. So there itself, we will lose most of the efficiencies. So we should look at some closed loop solution which will not burden the operator. Okay, I mean, which will take on top of the DCS as a supervisory control, and look into the different loops in your power plant and try to optimize for different bands of operation. Like say, if I have the visibility that how I operate the plant for say different duration, so I can define that range. So maybe from say 70 to 20, okay, or maybe from 50 to 70, or even below 50 to say 30 to 50%. So in each band, you can actually say optimize the operation and tell the final controller that these are the kind of biases you have to take, okay, in order to have the optimal operation at each band of operation. So the normal analytics will not give this kind of feedback or the kind of operational feedback to the DCS. So we need a closed loop solution, which is working in tandem with your DCS, and the DCS has to work, take these signals and optimize the operation of the controllers, the final controllers. So boiler modeling and simulation, also one of the solution we should be looking at, because boiler is always seen as a black box. Okay, so we need to have more visibility into the boiler operation so that the people can actually see if there is any kind of impact from the fuel that you are firing, because we have seen there are a lot of changes in coal which is happening around. I mean, for most of the plants. So it is not at all near to the design coal or coal analysis now. So we have seen blending. We have seen ultimately totally different coals are being fired. So before we choose that decision to fire a particular coal, okay, am I get a visibility that what could be the impact on my boiler in terms of efficiency or in terms of the life impact? So this is a very base requirement for most of the operators in order to choose the most suitable coal for their boiler, which can actually say reduce the life impact and enhance the efficiency of your boiler. And combustion modeling and tuning as required, definitely this is one of the area which we should be looking at when the flexible operation is being talked of. So these are because any action on the power cycle, okay, so which has to be done quickly and if possible on a real time, so that the optimization can happen almost on a near real time basis, which will reduce which will provide a lot of say cost benefit to the operator in terms of the efficiency upkeeping at the optimal efficiency levels. The BOP equipments and system optimization, we can always look at the analytics and related operator action for optimizing the balance of plant equipment or systems. Okay, because they are not so critical, so that the operator will have time to act upon that, and also it may not cost so much compared to the power cycle. So BOP optimization, BOP optimization, basically we will look at the continuous monitoring and analytics if it is available for the particular equipment or system. So power cycle chemistry, I think I have just mentioned about the importance of power cycle chemistry. So here also we should have a proper monitoring and analytics related solution. So this is the overall technology stack that we can look at immediately in order to improve the situations in most of our power plants. So how are we placed to cater to the requirement of most of the power plant operators in this country? We have seen a lot of, say, renewable integration requirement for the captive plants. Okay, especially say if it is a steel plant or chemical plant where renewable integration is being talked of. So you may have some captive units. Okay, so when we are having a lot of renewable energy that has to be intake to the plant, so your in-house generation, which is normally a coal-based or thermal generation, which has to be say lower on the load. So mostly, and based on the variability of the renewable power, you will have to again say ramp up or ramp down on a maybe on a day-to-day basis. So that will also give a lot of flexibility requirement for the captive plants. Okay. So I was talking about the flexibility requirement for the IPPs, which is obviously known to everyone due to the grid requirement. But this is happening for the captive plants also.
Mr. Subhramanyam,
Yeah.
sorry to interrupt, would like to request if we could cover it little at a faster pace so
Yeah.
that we are getting at least 5-7 minutes for the discussion.
Exactly.
By 5:45, we are trying to conclude the session. Thank you.
Yeah. So I will just make a little faster movement on the slides. So we are customer centric. We are having automation and say our own developed solutions. Okay. So we like serve across reliable, renewable energy, battery energy storage, pump storage, hydrogen or ammonia power systems, and the operators. So we are believing digital plus domain solutions for, and which will make very comprehensive solutions for the power plant in order to cater to these kind of challenging requirements. So our leadership on the first of its kind of projects as well as the power will provide a lot of leverage in terms of say building new models, okay, or new innovative solutions for the plants, which is one of the prime requirement at this point of time. So any solution which we are seeing in on digital space, okay, so it has actually come through some innovative means of someone. Okay, so if you know the domain very well, okay, so you can innovate seamlessly and provide say a lot of innovative and optimized solution for the operator. So we have got the partnership for the entire stack of our solutions, because in digital space, as we all know, okay, so there is no single provider can have the complete comprehensive solution offered on the space. So we have to power the most optimized offering from the selective players who are providing the niche solutions in that area. So we power with an umbrella of partnership for most of the digital solutions. So we call it as a digitally powered efficiency enhancement program. Okay, so in which we take the data from the plants. Okay, so we diagnose for the performance deviations from through digital means, because which is very quick and very accurate. So if we evaluate the remedial measures from the analysis result, we will get different insights related to the performance of the plant. So we evaluate as well as we will also support with the remedial measures. And we also have the implementation assistance, because say there may be multiple solutions available with say maybe with the different ROIs. So we will look at the low hanging fruits initially in order to improve the implementation aspects in plant, because if you get the low hanging fruits say getting done at the plant, so which will provide a lot of say dialogue within the plant, and that will pave way for a platform based a long digital, I mean a higher digital transformation exercise for the plant. So we also have very smooth coordination with the operators, and we provide very practical solutions, because we have operators with us. We have also design and as well as the construction and maintenance engineers with us. So we see the entire spectrum of requirement from our operators, I mean from our engineers itself. So we go with a step-by-step approach, because say for remedial measures, we will have multiple solutions available. So we will go step by step by attacking the low-hanging fruits initially, and then go on to the larger capex capex items at a later point of time. So we also monitor those plans on a continuous basis, or maybe at an intermittent level, in order to ensure that the solutions are sustainable in the plan, so that whatever benefits we are assuring, that is sitting in the plan for their benefit. Yeah, for a flexibility part, we have seen say change in operation procedures. Okay, so change in monitoring systems to enhance the operational flexibility. So control system related optimization. I was mentioning about the advanced process controls. So the advanced process control implementation for any performance improvement or heat rate improvement requires some kind of base layer optimization as a part of the initial model building as well as the solution implementation exercise. So that also will require some kind of solution automation within the plant. If some of the PID loops in the plants are not automated properly, so we will have to first attack on that. Okay, so make it in automated phase, and then connect to the advanced process controllers for the the global level optimization in the plant. So how these advanced process controllers, which is optimizing the heat rate, works? So it is actually, it's a closed loop solution which works in tandem with the existing DCS. So it also look into the multiple control loops simultaneously, which is normally not possible for an operator. So we are actually leveraging the capability of a dynamic mathematical model based simulator within the this particular software. So we build the model based on the opportunity available within the plant. So within the initial say digital diagnosis, okay, we will come to know where are the opportunities available in the plant, and which are the loops that opportunity is really available. So based on that, we will develop the model for different range of operation, so that in each of the range, the model will actually will deliver an optimized operation. So which ultimately enhance the part load efficiency operation in a big way. So there are digital point solutions, okay, which are looking only to the certain systems or equipments, and then optimizing the operation of the system or equipment very specifically. So we have seen the point solutions available for say boiler performance modeling and simulation, power cycle chemistry monitoring and simulation, for pump performance monitoring and simulation. Okay, similarly also we have remote energy analytics available with us. So cooling tower model performance optimization, which will reduce the auxiliary power consumption in a significant way, based on the optimized operation of the cooling tower based on the weather conditions. So I'm not getting too much into the details of each of the point solution. I'll leave the slide with all of you. So you can, if you have any queries related to the digital point solutions, okay, I can always get back to you with the right answers on that. So, but one point solution I would like to explain little detail. Okay, that is about the boiler modeling and performance simulation tool. So this actually is a physics-based tool. Will predict the temperature profile across the different sections of the boiler with a different type of coal. So from the predictions, we can make out what are the type of heat transfers happening at different sections of the boiler, which is normally not available to an operator's, a plant operator. So this will give a lot of insight into the maintenance aspects of the boiler. Okay. The second aspect is, before you fire any coal, I can fire that coal in this digital tin of the boiler and understand what could be the health impact as well as on the performance impact. Okay. So ultimately, this can be used as a purchase decision making for the fuel. So that is one aspect. The second part is, see, I would also know that what could be the temperature excursions that are happening when I am firing at a particular coal, and what are the kind of thermal cycling I will have to thermal cycling which is happening. So for a thermal stress prediction point of view, okay, so such kind of part load operations can be simulated, and that can be given as an input for the thermal cycling scenario, and in order to predict the impact on the plant, the boiler life or pressure parts life of the boiler. So this is one of the solutions which I would like to talk about in little detail. So the second option was on the water chemistry monitoring as well as analytic solution. So here also the solution works on a near real time.
Mr. Subhramanyam, apologies for interrupting again, but actually due to time, actually we are getting little more stressed than what we planned for. So possibly if you could conclude within next 2 minutes so that we can take some last 1 or 2 few questions and then conclude the session. So I'll appreciate that.
Sure. I'll just stop with this particular slide. Okay, so I would like to just mention that the water chemistry normally is a very not very much attended areas for most of the Indian power plants. Okay, but when the flexible operation comes in picture, this will become one of the area which people have to look into little focused. So the point solutions will look into the real-time data or sampling data from multiple sampling locations, and it will get into the trend of each of the sampling parameters, and it will correlate with respect to the sampling data from multiple locations to give the most accurate prediction about the deviations, if any. So if there is any deviation, it can look into the root causes and it will predict the root causes spontaneously to the operator so that he can take action then and there with respect to the water chemistry. So most of the digital point solutions, it will look into the particular equipment or system operation. If there is any performance deviation, it can detect very fast due to the inbuilt engine within the point solutions. And it can also provide the operator with a sufficiently described detail for the root causes. So which will in fact assist the operator to take action very quickly and optimize the operation around that particular equipment or the system. So this is the overall on some of the solutions or the technologies that we can look at immediately to counter most of the impacts related to the energy transition, the ongoing regulatory challenges on the power plants, and something which is from a practical point of view. So this is what I think briefly I would like to cover in this presentation. So most of the slides for the point solutions are available with with all of you after this presentation. So if you have any queries related to the solutions, please feel free to connect with me. So I am there to answer any of your queries related to these solutions. And many of the solutions are actually under piloting, or say we have implemented references. So whatever we have talked about. So cooling tower, we are in the process of implementation. Okay, so boiler we have implemented to one of the client. So we are talking for a long-term deployment now. And for the advanced process control solutions, so we have got multiple references across globe. So with this, I would like to conclude, and the floor is open for Q&A now.
Great. Thank you so much, Mr. Subhramanyam, for the detailed session, and definitely very interesting points you have covered today. But yes, due to the timelines we have to adhere, we are actually missing on a lot of key notes from your side, but definitely for some other time.
No
But in the
problem.
meantime, I would now open this forum to our esteemed panel members and our attendees to ask questions. So over to you, people. Just please put forward your questions to Mr. Subramanian, and let's hear it out. So Sandeep ji, Prabhat ji, and any questions from your side?
Yeah, nothing. Kaushal, I would congratulate Mr. Subramanian because this is a very pertinent topic nowadays. As
Right.
solar coming in to the grid, all of the thermal power plant that we have in our country are going to face this. So it's better to be prepared than to be like later on finding and or like looking for the solution at that time. Uh, it's a very good thought that has been put by Mr. Subramanian. Congratulations for this.
Yes.
Thanks,
Great.
Sandeep. Yeah.
Mr. Prabhat. Okay, he left, I think. So, any other attendees would like to post any questions, or shall I ask my last question to Mr. Hello.
Yeah, I think you can
Okay.
ask your questions and we could
Okay.
conclude the
Yes.
session.
Yes, we can conclude. So, yes. So, Mr. Subramanian, just one last question. So, as I asked Mr. Sandeep also, so in terms of the commercials, how exactly is your track record, or what is the ROI of your solutions? And what is the benefit to the end operator or the implementer? So, would just throw some light on that.
Yeah. See, there is no general, there is no general answer to this. Okay. So it has to be specific to the plan, to the kind of solutions that we are looking at. So, but I can tell you, see, for a power plant of an aged power plant, okay, so where say at least a good amount of automation available, okay. So with the kind of the heat rate optimization solution through advanced process control can give maybe a payback of say 1 year. Okay, so
Okay.
which is normally, I think it should be driving the implementation opportunities for that such kind of solutions. Say for cooling tower, we have seen say 20 to 30% energy saving.
Okay. So
So
these solutions references are available in India or abroad, or how exactly
yeah,
it is currently working?
for the advanced process control based heat rate optimization. Okay, so we have global references available. So in India, we are actually talking to a couple of customers now. Okay, so which will soon, I think, we will have references in India as well.
Great, great.
Yeah.
So
For cooling
that
tower,
is all
yes,
I
we have.
think.
Yeah, we have some
Okay.
implemented references in India. So for boiler also,
Right.
we have some implemented references in India.
Great, great. So I think that is all from my side, Mr. Subramanian, and thank you so much for your answers. And now, I mean, going forward to the conclusion of the session, so I would like to thank both of our panel members, Mr. Sandeep and Mr. Subramanian, and also Shayal for this opportunity to be here with you all guys on this CE platform and having me here as a moderator. And I really enjoyed connecting with you all. I learned a lot today on the either it on be on the industry X or on some other solutions offered by TC. So definitely a enlightening session. And thank you so much for having me here. And over to you, Shreya.
Thank you. Thank you so much, Mr. Vaishnav. I think it's been a very a long day for all of us, but I would say a very rich day because there's been a lot
Indeed.
discussed right from morning till here. We started at 10:15 today morning, and it's been back-to-back sessions and back-to-back feeding of information. I am
True.
sure this has been fruitful to all our attendees and also the speakers who have been with us session after session, not only theirs. So thank you, Mr. Vaishnav, for leading this session for us, and thank you, Mr. Chittora and Mr. Subramanian, for your presentations and sharing your insights with us. It was indeed an informative session. And ladies and gentlemen, with that, we come to an end of day one of our conference on the second annual Heat Rate Efficiency 2022. Do not forget to join us tomorrow as well. And tomorrow is going to be the day 2 of the conference. We would start 10:15 onwards for a much interactive day again with industry heads. And the sessions to be discussed tomorrow would include heat rate and flexibility, coal-fired generation units, encountering challenges while boosting the heat rate performance, boiler efficiencies, fuel management, spotlight presentations on coal-based power plants, heat rate improvement and repowering, a way forward towards decarbonized future, and a session on voluntary carbon market. This will be followed by a much awaited awards. So just the panel discussions and the 2-day conference is not it. We concluded with a bang. We would be having the much awaited awards, which is the 2nd annual CE National Energy Efficiency Awards. So do stay tuned with us tomorrow as well. And for now, I shall take your leave. Just wishing you a great evening ahead, and I will see you tomorrow. Thank you so much.
Thank you. Thank you.
Thank you. Thank you.
Thank you.
Thanks.